Hey guys, so today we're going to talk about mensuration. So in this video, I tried condensing the entire chapter into a single video so that you can refer to this video right before your exam or while doing your assignments. So here I divided the video into 3 different levels: easy, medium, and difficult. So the easy is the first level, which are mostly formula driven questions where you just need to put the formula to get the answer. Next we have medium level questions which do not have a direct formula, so you have to use other ways to get the answer. Next we have level 3, which is the difficult questions. These are the actual previous year questions that I'm going to show you how to solve step by step so you can get full marks. So yeah, without further ado, let's get started. So the first question we have: a trapezium of area 105 centimeters square has parallel sides of length 5 and 9 centimeters. How far apart are the parallel sides? So basically they're asking you to find the distance or the height of the trapezium. Now let's just draw a trapezium. Oh, let me just draw that again. So this is 5, 9. They want you to find the distance between these two parallel sides. So the area of a trapezium is given by the formula half a plus b into h. Area is already given in the question, so let's just put that in the equation here. Half a and b are the lengths of the parallel sides. 5 plus 9 h. So 105 equal to 7h. H equal to 105 by 7, which is 15 centimeters. So that's the distance between the parallel sides. Okay, so next up we have find the area of triangle ABC where AB equal to C, AC equal to B and BC equal to A. So let me just draw the triangle first here. Let this be ABC. So this side becomes A, this is side B, this is side C. So they've given the measure of two sides. So B is going to be 3.2 centimeters and C is 1.8 centimeters. And they've also given two angles here. So let's just mark that. This is 10 and this is 65 degrees. So the usual formula for the area of a triangle is half base into height, but we don't have height here. We just have two sides and two angles. So we're going to use an alternate formula, which is half BC sine A. So B and C are the lengths of the sides. So this can be any two given sides in the triangle, and this is the angle between the two sides. So this is called the included angle. So since we're given B and C sides here, we're going to take A as the included angle. Let's say in the question, if you're given side C and side A, you're going to be taking B as the included angle. And if you're given side A and side B, you're going to be taking C as the included angle. So anyways, for the question here, we have A as the included angle, which we can easily find out by just subtracting it from 180. So this is 180 minus 75. This turns out to be 105 degrees. This is equal to half 3.2 into 1.8 sine 105. And when you solve this, you get 2.78 centimeters square. Next up, we have find theta when r equal to 5 centimeters and l equal to 7.5 centimeters. So L is the arc length here. So let's start with the formula for arc length, which is theta by 360 into 2 pi r. And arc length is already given. It's 7.5 equal to theta by 360 into 2 pi r, which is 5 centimeters. And when you solve it, you get theta equal to 85.9 degrees. Now remember guys, whenever you're solving sums that involve pi, do not use 3.14 or 22 by 7 in your calculator. Just use the pi symbol itself unless instructed otherwise. Otherwise, you'll get an inaccurate answer. Next, we have find the shaded area when r equal to 6 centimeters and theta equal to 70 degrees. So in this circle, we have r as 6 centimeters. So basically this is going to be 6 and this is going to be 6 as well. And theta is equals to 70. So this is 70. And we are supposed to find the shaded area, which is the area of this minor segment. And the way that you do that is you're going to take the area of the entire sector which is this. This is the area of the entire sector, this complete sector. And from that, you're going to subtract the area of this triangle. And what is left will be the area of the minor segment. So let's put that into a formula. So area of segment is equals to area of sector minus area of triangle. So that is theta by 360 into pi r square, which is the formula for area of sector, minus area of triangle, which is half AB sine C. So that is 70 by 360 into pi r square minus half. AB is 6 centimeters because it's an isosceles triangle, and C is going to be 70 degrees. So when you solve that, you're going to get 21.99 minus 16.91, which is equal to 5.08 centimeters square. So this is the area of this pink colored area. Next, we have a prism has volume 100 centimeter cube and length 8 centimeters. If the cross section is an equilateral triangle, find the length of a side of the triangle. So first, let's just draw a prism here so that it's easy to understand. So this is what a prism looks like. They've given us the total volume of the prism, and they've also given us the length of the prism. So let's start with the volume. Volume equal to cross-sectional area into length. Now this formula is generic for all 3D figures. For any 3D figure, a regular 3D figure, if you want to find out the volume, it is the product of cross-sectional area and length. So here volume is 100 as given in the question, cross-sectional area we don't know, and length is 8 centimeters. So when you do the calculation, you get 100 by 8, which is 12.5 centimeters square. This is the area of the cross section. Now they've told you that the cross-sectional area is an equilateral triangle, and you need to find the length of the side. So let's just draw the diagram here. This is an equilateral triangle. So every angle is going to be 60 degrees. And we also know the area, we just found it. So area is equals to, area of a triangle is equals to half AB sine C is equals to half. I'm just going to write A because they're equal in measure. Sine 60 degrees, this is going to be equal to 12.5. And when you solve this, you get A square is equals to 28.86, where A is equals to 5.37. So this is going to be the length of the side of this triangle. So in this figure, if I have to depict, this part is going to be 5.37 centimeters. Next, we have a cone is attached to a hemisphere of radius 4 centimeters. If the total height of the object is 10 centimeters, find its volume. So this is a cone and it is attached to a hemisphere of radius 4 centimeters. So this is a common radius that both the cone as well as the sphere share. Now the total height of this figure is 10 centimeters. The height of the cone would simply be 10 minus 4, which is 6 centimeters. Why 10 minus 4? Because the radius of the sphere is 4 centimeters. So this distance is going to be 4. And the remaining is going to be 6. And when you add that up, the total height of the object comes out to be 10 centimeters. So let's start solving. The total volume is going to be volume of cone plus volume of hemisphere, and the volume of cone's formula is 1 by 3 pi r square h. Volume of hemisphere is 2 by 3 pi r cube, and just substitute r equal to 4 here, h is 6 for the cone, and for the hemisphere 2 by 3 pi, r is simply 4. cube. Now you get 32 pi plus 42.67 pi. When you solve this further, you're going to end up with 234.58 centimeter cube. So that's the total volume of this entire figure. Okay, so here we have a golf ball has a diameter of 4.1 centimeter and the surface area has 150 dimples and radius 2 millimeters. Calculate the total surface area which is exposed to the surroundings. So first let's take a look at this golf ball. If you look at this golf ball, it's not a regular sphere. The reason is we have dimples on the surface. So the surface area which was supposed to be here is missing. And also additional surface area is introduced because of these dimples, like this. So let's try to solve this sum by coming up with an equation first. So we have surface area is equals to, this is the total surface area, is equals to surface area of ball, which is the total surface area of the sphere, minus area of 150 gaps. By gaps, I mean these little spaces where there was supposed to be material, but there isn't because of the dimples, and plus 150 hemispheres. So like I said, because of these dimples on the golf ball, we have additional surface area being introduced in the form of a hemisphere. So we got to add those. So let's write the equations. This is equal to surface area of ball is 4 pi r square minus 150 gaps is simply 150 into surface area of those gaps, which is just pi r square plus 150 into 2 pi r square, which is the formula for surface area of the hemisphere. Now by r, by here r I mean the radius of the entire ball, which is 4 pi into 4.1 by 2 square, because the diameter is given to be 4.1, so the radius is just the half of it, minus 150 into pi r square. By here r I mean the radius of the dimples, which is 0.2, and we have next 2 pi r square, which is again 0.2 because we're talking about the dimples here. So when you solve that, you get 16.81 pi minus 6 pi plus 12 pi, and when you simplify it, you get 71.659 centimeters square. So while you're doing the calculations, just take pi as it is in your calculator. Do not change pi ka value into 3.14 or 22 by 7. Just click the pi button on your calculator when you're calculating. So this is the answer. Alright, so we have calculated the volume of a regular octahedron whose edges are all 10 centimeters. So if you look at this diagram, you will just realize that octahedron is basically two square base pyramids, one on top of each other. So to find the volume of octahedron, you're just going to take the volume of square base pyramid and multiply with 2. That's it. That's how you get the answer. Easy, right? Not really. Why? Because here, for you to find the volume of the square base pyramid, you need the height of the pyramid. We are not given the height. We're just given the base, sides of the base, which is 10 centimeters. So the first task is to find the height of the pyramid. So let me just try to draw it in the figure here so that you understand. This is the height that I'm drawing from, let's say this is point A, and it touches the pyramid's base at point O, and you can join it to one of the corners, and let's call this as B. So if I have to draw a clear diagram of this, it will look something like this. This is going to be A, this is O, this is B. This is the height that we have to calculate, and OB is basically the half of the diagonal of the square. So the base is a square, right? So just the diagonal, half of the diagonal of it is the OB. So for a square whose size is 10 centimeters, the diagonal is 10 root 2. And half of that is going to be 5 root 2. This is 5 root 2. And next we have AB. AB is already given in the question. It's 10 centimeters. So you just have to find the height here by using the Pythagoras theorem. So h square plus 5 root 2 square is equals to 10 square. When you solve this, you're going to end up with h equal to 5 root 2. So this is the height of the square base pyramid. Now since we have the height, we can easily calculate the volume. So let me just write it here. Volume of octahedron is equals to 2 times volume of pyramid. That is going to be 2 into 1 by 3 base area into height. This is the formula for volume of pyramid. 1 by 3 base area into height. So this is 2 into 1 by 3 base area is 10 square into height. We just found out what the height is, 5 root 2. And when you solve this, you get 471 centimeter cube. So that is the volume of this octahedron. Okay, here we have a frustum is a cone with the end chopped off. A bucket in the shape of frustum as shown has diameters 10 centimeters and 4 centimeters and a depth of 3 centimeters. Calculate the volume of the bucket. Now, right off the bat, we do not have any direct formula for frustum in your syllabus. So we're going to get a little creative and try to find an equation so that we get the volume of the bucket. So let's try to draw the complete cone. Had the end not been chopped off, this bucket would have simply looked like a cone and would have looked something like this. This would have been the height of that cone. This would have been the radius, which is half of 10, 5 centimeters. And this simply would be 2 centimeters, half of the diameter, 4 centimeters. So let me just try to redraw this again clearly so that it's easier for you to understand. So let me take this point as A, B. Let's take this as M, N. Let's take this as C. This is 3 centimeters, that's the depth of the bucket. And this is 5 centimeters, that's one of the radius of the bucket. This is 2 centimeters, that's another radius of the bucket. And this is H. This would have been the total height of the cone had it not been chopped off. So why am I emphasizing on H here? Because to calculate the volume of the cone, you require the height of the cone. So we're going to get a little creative here and try to use trigonometry to find out the height here. So let's just take an angle theta over here and try to use trigonometry. So in triangle ABC, if you take tan theta, that would be 5 by h. Let this be equation 1. Let's take another triangle CMN. Again here, let's try to take tan theta. That would be simply 2 by h minus 3. Why? Because this is h minus 3. So this would be equation 2. When you equate 1 and 2, you end up with 5 by h equal to 2 by h minus 3. And when you simplify this, you just get h equal to 5 centimeters. Okay, so this is part of the problem solved. Now we know the height of the entire cone. So how to calculate the volume of the bucket now? So to calculate the volume of the bucket, you simply have to take the volume of this entire cone and subtract the chopped cone from it. So let me just write it here. Volume of frustum is equals to volume of complete cone minus volume of the chopped part, the chopped cone. This leaves you with the volume of the frustum. So that would be 1 by 3 pi r square h This is R1 H1 actually, because you have two radius and two heights, right? So you'll get confused. So that's why I'm taking R1 H1 minus 1 by 3 pi R2 square H2. So this is 1 by 3 pi. By R, I mean the radius of the complete cone. So the radius of the complete cone is 5 centimeters and the radius of the chopped cone is 2 centimeters. So here I'm going to take radius of complete cone 5 centimeters, height of complete cone 5 centimeters minus 1 by 3 pi, radius of the chopped cone 2 centimeters and height of the chopped cone 2 centimeters. So we're gonna get, after solving, we're gonna get 123 centimeter cube, and this is the volume of the frustum or the volume of bucket. So when you're calculating, let me remind you again, use the pi button in your calculator. Do not take pi value as 3.14 or 22 by 7. Alright, next up we have rain which falls onto a flat rectangular surface of length 6 meters and width 4 meters is collected in a cylinder of internal radius 20 centimeters. What is the depth of water in the cylinder after a storm in which 1 centimeter of rain fell? So basically in this question what you're doing is transferring the water from a cuboid, because we are talking about a flat rectangular surface, right, on which 1 centimeter of rain fell, which means it basically just turned into a cuboid. So we're transferring the water from a cuboid into a cylinder. So the volume of water in this cuboid is equal to the volume of water in this cylinder. In simple terms, that's what it's going to be. So if I have to draw a diagram and explain it to you, this is the flat rectangular surface on which rain fell up to 1 centimeter. So now it just transformed into a cuboid, right? So let's first calculate the volume of cuboid here. So that is L into B into H. Length of the cuboid is 6 and width is 4 meters. It's given in the question, and the height is 0.01 meters. So they've given in centimeters. I just converted that into meters. So after this we get 0.24 meter cube. This is the volume of the cuboid. Now we're going to equate this to the volume of the cylinder, because we are transferring the water from the cuboid to the cylinder. So the volumes are going to be equal. Volume of cylinder is given by the formula pi r square h, where volume of cylinder we already know because it's equal to the volume of cuboid. So that's 0.24 equal to pi. Radius is 20 centimeters. So let me just convert that into meters. That would be 0.2. And h we don't know. We have to calculate. So here we get h equal to 0.24 by 0.04 into pi. And when you simplify it, you get h equal to 1.91 meters. So this is the depth of water in the cylinder after the storm. Here we have water flows through a circular pipe of internal diameter 3 centimeters at a speed of 10 centimeters per second. If the pipe is full, how much water flows from the pipe in 1 minute? So to calculate the water volume of water that flows in 1 minute, we should first know the volume of water that flows in 1 second. So here let's just draw a pipe. So the speed of the water jet is 10 centimeters per second, which means it flows across a distance of 10 centimeters in 1 second. And the diameter of this pipe is 3 centimeters, which means the radius is 1.5 centimeters. So first we need to calculate the volume of water in 1 second. So that is V is equals to pi r square h. That's the formula for volume of cylinder. So that is pi into 1.5 square and h is height. H is basically this distance. So that is the height of the cylinder, that's 10, is equals to 22.5 pi centimeter cube. That's the volume of the cylinder, volume of the water that flows in 1 second. So for 1 minute, you're just going to multiply this value with 60. So that would give you 4241.15 centimeter cube. Now they're asking you to answer in liters. So you just have to convert centimeter cube into liters. So the conversion looks something like this. 1 liter is equals to 1000 centimeter cube. So this is basically going to be converted into 4.241 liters. That's the answer. Okay, here we have a regular hexagon is circumscribed by a circle of radius 6 centimeters. Find the area shaded. So here let me just take the center. Let's start with the center of the circle and try to join it to the corners of the hexagon here. Now since this is a regular hexagon, each of these parts, each of these triangles that you see are going to be identical. Each of them are going to be same area. So if you have to cut up the entire 360 degrees, the angle around a point is 360 degrees, right? So this entire angle is 360 degrees. So if you have to cut that up into 6 equal sections, so each would be 60 degrees. That means if you take a regular hexagon and try to cut it up into 6 parts, each part is going to be an equilateral triangle. So let me just consider one single section so that's easier for you to understand. Here the question is, they're asking you to find the shaded area. That means if I can find the area of this entire sector, and from there if I can minus the area of just this triangle, I'll be left with the shaded area. So basically this is finding out the area of a segment. You do not have a direct formula for finding the area of the segment. You have to take the area of the sector and from there you have to minus the area of the triangle, and that's how you get the area of segment. So here there are 6 segments here, so I'm just going to multiply my answer with 6. So let me just show you step by step. Shaded area equal to sector area, the entire sector, minus the area of triangle. And this thing I'm going to multiply with 6 because we're talking about 6 sectors here, like this. So this is 1, 2, 3, 4, 5, 6. So that would be theta by 360 into pi r square. That's the formula for sector area, minus half AB sine C. That's the formula for the area of a triangle, and multiplied by 6. So that would be theta is 60 degrees, as I already explained. All of these are equilateral triangles because it's a regular hexagon. So 60 by 360 into pi r square. R is 6 centimeters, it's given in the question. Minus 1 by 2. So if you consider this triangle, here this is 60 degrees, this is 6 because this is the radius, even this side is 6 centimeters because even that is the radius. So that would be 6 into 6 sine 60 degrees into 6. This will be 6 pi minus 15.588 whole multiplied by 6, and when you simplify it you get 19.6 centimeters square. So that is the area of the pink region in the diagram. Okay, first up we have this question which appeared in a recent previous year paper. So let's try solving this. Here we have a prism A, B, C, D, E, F, and the first question is we're asked to calculate the total surface area of a prism. So this prism has 1, 2, 3, 4, 5. It has 5 sides, 2 triangles and 3 rectangles. So you just have to find the area of each and add them up to get the total surface area. So TSA, total surface area, is equals to area of 2 triangles plus area of 3 rectangles for this prism. So before that we need to find few measurements. So we have to find BC here. So in triangle ABC, it's a right angle triangle, as you can see. It's right angled at B. So we can apply Pythagoras theorem. AB square plus BC square is equals to AC square. And AB is 13 plus BC square is equals to 20 square. And when you solve it, you get BC is approximately equal to 15.2 centimeters. So BC is 15.2 centimeters. Let me just write it here. Yes, so now since we got BC, we can calculate the area of each side and then add them up. So let me just do that. The triangles here, by the way, are identical. Triangle ABC and triangle DEF, they're identical. So I'm just going to take the area of one triangle and multiply it by 2. So let me just write it here. Total surface area is equals to half into area of triangle ABC, base into height 13, and I'm multiplying it with 2 because we have 2 triangles here which are completely identical to each other. And then we have side ADFC, whose measurements are 20 into 24. And then we have side ABED, whose measurements are 24 into 13. And then we have the other side, BECF, sorry, and that would be 24 into 15.2. So just add them up, you get 13454 approximately. So this is the surface area, the total surface area of this prism. Next part of the question, we have calculate the volume of the prism. So the formula for volume is area of cross section into length of the prism. So area of cross section is, I can just take the area of cross section of this triangle and multiply it with its length, which is 24 centimeters. So let's just do that. We get half into base is 15.2 for the triangle and height is 13, and we're going to multiply it with the length, which is 24, and we get 2371 centimeter cube as the volume. That is the volume of this prism. Next we have calculate the angle that AF makes with base BCFE. Okay, let's try to figure out what we are doing here. So we are talking about the angle that AF, this line, makes with BEFC, which is the base, this, the rectangular base. So what we're going to do is draw a line here that's joining the line AF to the base. So I'm just going to take the diagonal BF and the line AF, which is already given in the question, and try to find the angle between them. So this would be my answer. So for that we need to find a few things before. So consider triangle ABF. Here I can find this theta simply by taking sine theta equal to perpendicular upon height, because this is a right angle triangle. ABF is a right angle triangle at B. So we can use sine theta equal to perpendicular by hypotenuse. But here we do not have the hypotenuse. So let's just find that, which is AF. Let's try to find AF. So for that, let's consider triangle ACF. So in triangle ACF, again, this is its right angle at C, and because it's a rectangle, so it's right angle at C. So let's find out AF here. AF square is equals to AC square plus CF square, which is equal to 20 square plus 24 square. AC is 20 and CF is 24. So yeah. Next, AF is equals to root over 400 plus 576, which means AF is equals to 31.24 centimeters. Okay, so now we got AF. We can use the sine theta to figure out the angle there. Let's do that. So sine theta is equals to, perpendicular here in this triangle is 13 centimeters. This is the perpendicular. So that's 13 centimeters divided by hypotenuse, which is AF itself. So that is 31.24. And when you solve it, theta equal to sine inverse of 13 by 31.24. You get theta equal to 24.59 degrees. So that's the measure of this part. This angle is 24.59 degrees. That is the angle that AF makes with the base BCFE. So whenever you are asked to find out the angle between a line and a base, just draw a diagonal to the base and find the angle between the diagonal and the given line. Okay, next we have another previous year question here. The diagram shows a solid pyramid with a rectangular base ABCD. And the first question is, the pyramid is made up of wood and has a mass of 800 grams. Calculate the density of the wood. So to calculate the density, they've already given us the formula mass by volume. So mass is given in the question, which is 800 grams. We just have to figure out the volume and use this formula. So let's do that. Here, to find the volume of this pyramid, you just have to use the formula given here, 1 by 3 into area of base. Here the base is rectangle ABCD, so area of base rectangle ABCD into height. Now we have the measurements of rectangle ABCD, the length and width, 18 and 15, but we do not have the height here. So let's just try to find the height first and then use this formula. So to find the height, let me just consider a triangle EDC. So in triangle EDC, by the way, this is a right angle triangle. It is right angled at D, this triangle. So we can use the Pythagoras theorem. So ED square plus DC square is equals to EC square, and ED square is equals to 24 square, which is EC square, minus DC square, which is 18 square. So if you solve that, you get ED equal to 15.87 centimeters. So now you know the height. This is 15.87 centimeters. So let's use that to find the volume now. Yeah, so this is 1 by 3, area of base is 18 into 15, into height is, we just found out, 15.87, and when you do the calculation, you get 1428.3 centimeter cube. Sorry, this is volume, so make sure you write the measurements properly. So next we have density. That is the question. We have to find the density. So let's just use the formula mass by volume. That would be 800 divided by 1428.3. This is 0.56 grams per centimeter cube. So that's the final answer. That's the density of this shape. So this is, if you notice, it's a 5-mark question, guys. So make sure you write your answer in proper steps. Do not use shortcuts or calculations. Do not miss showing the calculations, because your teachers are going to grade you based on those. Alright, next we have calculate the angle between BE and base of the pyramid. This is a 4-mark question. So let's try doing that. Yes, so the angle between BE and the base is a rectangular base. So let me just draw a line connecting BE to the base. So that would be the diagonal of this base. So we just have to find out this angle. Let's assume it's theta. So for this, take triangle EDB. In triangle EDB, you get ED is equals to 15.87. We just found out in the previous part it was 15.87. And BD is equals to the diagonal of the base. So how do you find out the diagonal of the base? Base is a rectangular area. So we just have to find its diagonal using the Pythagoras theorem. So that would be BD equal to root over 18 square plus 15 square. That would be BD equal to 23.43 centimeters. Now to find the angle here, I'm going to take tan theta, which is perpendicular by base. So here it'll be 15.87 divided by base, which is 23.43, what we just found out, this one. I'm sorry, that's my laptop. It misbehaves. Anyways, so theta equal to tan inverse 15.87 divided by 23.43, that is 34.11. So theta equal to 34.1 degrees. Alright, here we have another previous year question. So basically we're looking at a sector OXY, which is a part of a circle with center O and has radius 9.5 centimeters, and the sector angle is given to be 53 degrees. We are asked to show the area of sector is 41.7 centimeters square. So this is a pretty straightforward question. You just need to know the formula for finding the area of a sector, which is theta by 360 into pi r square. Let me just change the pen. Yeah. Theta is 53 degrees here, divided by 360 into pi into radius is already given 9.5 centimeters. So this would be 41.7 centimeters square. That is exactly what they're asking. Next up, we have the area of triangle OAB is 1/3 of the area of sector OXY. Calculate OA. So let me just write that in a statement here. Area of triangle OAB is equals to 1/3 into area of sector OXY. So that be half into the area of triangle can be written as half BC sine A, which is basically half into take two sides and the sine of the angle between them. So I'm going to take in triangle OAB, I'm going to take OA and OB, and I'm going to take the angle between them, which is 53 degrees. So let me just write it as OA into OB into sine 53. This is equals to 1/3 into 41.74, which we've already found in the previous question. We found the area of this sector. So that be half into OA and OB are of the same measure. It's a isosceles triangle. So I can just take it as OA square into sine 53 degrees is equals to 1/3 into 41.74. So OA is equals to, when you solve this, you get 5.9 centimeters. That's the measure of OA. Next up, we have the diagram shows a sector OPQ of circle with center O and radius 24 centimeters. The sector angle is 60 degrees. And with this, they've made a cone. So using this sector, they've made a cone out of it. So when you do that, obviously the curved surface area of the cone is equal to the surface area of the sector, right? So we're just going to use that logics. Area of sector is equals to curved surface area of cone. Now that would be 60 by 360 into pi into 24 square, because the area for sector is theta by 360 into pi r square. So I'm using that formula, is equals to curved surface of area of cone, which is basically RL. That's the formula for it. L, by the way, is the slanting height. So this is L, this is H, and this is R. Yes. So here, when we solve this, we get R is equals to 4 centimeters when you solve the equation. Now we know R and we know L, because L is 24 centimeters. L is basically the radius, right? So this is 24 centimeters. We know R to be 4 centimeters. We just need height, because for finding the volume of this cone, that's the question, right? We have to find the volume of the cone. For that, we need height. So let's just use the Pythagoras theorem here. Let's just consider this triangle O. Yes, let me just name this point as D. So in triangle ODQ, OD square plus DQ square is equals to OQ square. So that would be H square plus 4 square equal to 24 square. So when you solve this, you get H equal to 23.664 centimeters. So now you have the height. You just have to use that in this formula. That would be V equal to 1 by 3 pi r square into H, and get the volume, which is 396.49 centimeter cube. This is the volume of the cone. So what we've basically done in this question is we have turned a sector into a cone. So that means the area of the sector is going to be the curved surface area of the cone. So we equated that to get the radius of the cone, because we have to know the radius and the height as well. So yeah, we got the radius of the cone. With that, we used Pythagoras theorem to find out the height, and eventually we used this formula to find the volume. Next, we have a cylinder with radius 6 centimeters and height h centimeters has the same volume as a sphere with radius 4.5 centimeters. And you have to find the value of h. So this is a pretty straightforward question. You are just going to equate the volume of cylinder to the volume of sphere. So the volume of cylinder is pi r square h. I'm just going to take it as pi r1 square h, because we have two radiuses here. So we just want to call the radius of the cylinder as r1 and the radius of the sphere as r2, so that there's no confusion. And we have volume of sphere as 4 by 3 pi r2 cube. Here the radius of the cylinder is 6, so let me just put that into the formula, and the radius of the sphere is 4.5 cube, and when you solve this equation you get h is equals to 3.375 centimeters. So that's the height of the cylinder. It's a pretty straightforward question. It's almost a no-brainer. So yeah. Next we have a solid metal cube of side 20 centimeters is melted down and made into 40 solid spheres, each of radius r centimeters, and you're supposed to find the value of r. Again, this is also a pretty easy question. You know that the volume of cube, so the cube was melted down, so the volume of the cube as well as the 40 solid spheres is going to be exactly same. So we're just going to use that logic here, is equals to 40 spheres So that would be volume of cube is basically you just multiply length with height, which is basically all the same. So I'm just going to take it as R1 cube. R1 is the, let's say, the side of the cube, or let me just take it as a cube. This is much better. A is the side of the cube, and that is equal to 40 into 4 by 3 pi r cube. So I'm taking 40 because we're dealing with 40 spheres here, and that would be 20 cube is equals to 40 into 4 by 3 pi r cube, and when you solve this you get r is equals to 3.63 centimeters. So that's the radius of the small solid cube, that is solid sphere that's made out of the metal cube. Okay, next we have a solid cylinder has a radius x centimeters and height 7x by 2, and the surface area of a sphere with radius r centimeters is equal to the total surface area of the cylinder. So here again it's a direct question. You just need to equate the surface area of sphere and the cylinder. So surface area of sphere is equals to total surface area of cylinder. Remember guys, there's a difference between curved surface area and total surface area. Curved surface area basically means the curved portion of the cylinder, whereas in total surface area you also have to take into account the top area as well as the bottom. So on the cylinder you have a top circle and a bottom circle, right? So you have to take those areas into consideration as well when you're talking about total surface area. So let me just put that into formula here. It is 4 pi r square. Capital R is the radius of the sphere, is equals to 2 pi RH, which is the curved surface area, plus 2 pi r square, which is the area of the top and bottom of the sphere. So that would be 4 pi r square is equals to 2 pi into 7x square by 2 plus x square. So 2r square is equals to 9x square by 2. Take r on one side, everything else on the other side. So you get r square equal to 9 by 4x square. And then we have r equal to 3 by 2x centimeters. So that's basically the conversion. They've asked you to find an expression for r in terms of x. So r is equals to 3 by 2x. If you liked the video, please do like, share and subscribe. It helps us keep motivated to make more videos in the future. And also let us know in the comments which next chapter do you want us to cover.